Now let's try to understand two more important concept idea behind the DBSCAN algorithms. So the first one is the density edge and second one is density connected points. What is this? So first try to understand what is density edge. What is density edge? What is this? What is density edge algorithm? Sure. Density edge, the first concept, the 2 points. So first thing will better if you take this. Suppose let's take it is 1 point and it is another point. It is another point. Let's take it's called the Q, capital. So in graph theory, these 2 points are called the vertex. If you read the graph theory, and we will see using the simple graph theory how to construct a algorithm. We will see these things in the next series of lectures. But the point in graph theory, the point are called the vertex. In graph theory, these point are called the vertex. These points are called the vertex. Okay, and the connections between these two vertex, the connections between these two vertex are called the path, edge. Connection between these two paths is called the edge. Okay, these are the terminology in graph theory. Okay, now using this terminology, we will build the density edge concept. So the first thing that we have to remember, the two vertex point that we have taken here, these two vertex point must be a core point. These 2 point P and Q, first condition is these 2 point must be a core point. Must be core points. This is the first condition. The second condition is the distance between these 2 points. The distance between these 2 points must be less than epsilon. So the distance between P and Q must be less than epsilon. Okay, if these two conditions less than equals to, if these two conditions hold, then we call these the edge is called the dense edge. This is called the dense edge. So suppose let's try. Suppose let's take this is the P and this is the Q, and P and Q are the core points. P and Q are the core points. Now if this distance, I'm taking the green color. If this distance between these two, if this distance is less than epsilon, if this distance value is less than epsilon, then we call this edge. If this edge, suppose it will be better. Let this distance is d. If this d is less than equals to this epsilon value, then we call these connections is called the dense edge. Now these connections is called the dense edge connection. These connections is called the dense edge. Density edge. Okay, I think you got the idea how this terminology has used actually. Now let's try to understand the density connected points. What is this? What is this concept? Let's try to understand density connected point. What is this? These points are about. What is this density connect? So the first conditions The first conditions, the 2 points are called the density connected points. The first come into a point and the second is connected. Third one is density. So first take the 2 points. First take the 2 points. Suppose let's take P, this is P and this is Q. First conditions it will be P and Q must be a core point. This is the first condition. Must be a core point. This is the first conditions. P and Q must be a core point. Okay. Now the second thing that they are because this is the points actually at the end of this is the points, and they are maybe have some another points. Obviously, in our data set there must have some another point. Suppose let's take they are have 1 point, they are have 1 point, let they are have 1 point. These are the 3 points they have. Okay, if suppose let's call this point is the P1, let this point is the P2, let this point is called the P3 point. If this happen and the distance between P1 and Q, this is the density H that we have already built, that we have got the, if this distance is less than, suppose let's call this is the D1, let this is the distance from here to here, let this is the D2 distance, let this is the distance D3 distance, let this is the distance D4 distance, let, and age distance is less than epsilon, means our radius, age distance that we have taken here, age distance less than epsilon value. This is also less than epsilon value. This is also less than epsilon value. This is also less than epsilon value. If these things happen, then these age connections, then these things are called the density age value. If they already have seen this concept, if this means age things are actually now, age things are called the density age. These things are called now the density age. These are the density age. Similarly here also it is the density age. Similarly here also it is the density age. Similarly this one is also a density age. If these things happen, then this called the density age. Now the question now they are just see these things. Now from P to Q they have created a path. Okay, first point is if this is the density age, if this distance is density age, then obviously as the definitions of the density age, P and Q must be a core point. So P1 Q, P1 P2 P3 must be a core points. That's trivial. That what. So here we got that. P1 since D1 D2 D3 D4 are the densityest, that implies what? That implies our point P1 P2 P3 must be a core point. Must be a core point. Okay, now the path that we have built here, now the path that we have created here, this path I am talking about, I'm using here this blue color. Now this path that we have created here by simply using the density is, now this path is called the density connected points. Density connected points. These are the density These are the density connected points. Because of this, at the end of the day, we got P and Q. Everything is a point, and obviously every point is a core point. That's the thing that we got. Every point is a core point, and if each core point connected by simply using the density H, then the path is called the density. Then this path is called the density connected path, and the points that connected the density connected path are called the density connected points. I think you got the idea. What is density connected point? Okay. First conditions is it will be the core point. Second condition is it is connected through a density H, and second point is they are half density connected path between these 2 points. So if you just summarize this thing, these points must be core points. And density connected means there must have density connected edge between these 2 points. There must have density connected sorry, I'm just writing from here, density connected edges between these points. If this one has, then we call these are the density connected points. I think you got the idea. So we already learned these 7 ideas in the I think in the second lecture. We got the idea of the hyperparameter. We have learned the concept of the hyperparameter. We have seen there have 2 hyperparameters. First one is the mean points. Second, we got the epsilon. We got this. These are the hyperparameters. Now the second concept in the third lecture, we got the some basic points. In first third parameter that we have seen. using this hyperparameter concept, we have built these 3 points. First point is the core point. Fourth parameter that we have built the border point. And the fifth one is noise point. Okay. Now in this lecture we have seen the path is the concept of connections. I think it will be better language. We use this word, connection. Connections. By simple using these 3 concepts. By simple using these points, we have built the connection. First means the 6th parameter that we have built here, means the 6th parameter is built density H. And the 7th one is density connected points. Density connected points. Okay, these connections. These 7 parameter we have already learned. Now in next video we will see using these 7 parameter how we will build this DBSCAN algorithm. We will see. I think the idea, the mathematics behind these 7 parameter is clear. these three discussions. Okay, I think you got the idea. Now, by simply using these 7 parameter, how we will build the DBSCAN algorithm, we will see this thing in next video.